I'm suhas, Assistant Professor, Department of Pharmaceutics. So today we are discussing on the topic soaps and syndet bars, which comes in your cosmeceuticals. So what are soaps? What are syndet bars? We are going to discuss, and these are the contents that we are going to discuss in today's chapter. What is the definition of soaps and syndet bars? Raw materials used in soaps and syndet bars. Formulation of soaps and syndets. Manufacturing processes, soaps versus syndets. What is the difference, advantages and disadvantages of soaps and syndet bars? Soaps. So soaps are sodium or potassium salts of long chain fatty acids. When triglycerides in fat or oil react with aqueous NaOH, that is sodium hydroxide, or KOH, that is potassium hydroxide, they are converted into soap and glycerol. This is called alkaline hydrolysis of esters. Since this reaction leads to the formation of soap, it is called the saponification reaction or saponification process. So majorly what's happening here is a potassium salt of long chain fatty acids or a sodium salt of long chain fatty acids. When triglycerides in fats or oils. So when triglycerides react with this potassium salts or sodium salts, they are converted into soaps and glycerol. So that's how you are going to prepare your soap, or the definition of soaps. Syndet bars. The word syndet is derived from synthetic combined with detergent. So syn from synthetic, det from detergents. Technically, it refers to the binding that occurs between different detergents, also called surfactants or tensioactive agents. So these syndet soap surfactants are derived from oils, fats, or petroleum products that are processed in a wide range of chemical processes other than traditional saponification. Whereas in traditional saponification, you are using a plant extract. That's why from fat or oil. Here we are mainly focusing on synthetic extracts. So raw materials used is fats and oils, alkalis, and other additives. Some of the additives are antioxidants, whiteners, perfumes, surfactants, fragments, emollients, antibacterial agents, and opacifying agents. So fats and oils. Fat mixture containing saturated and unsaturated and long and short chain fatty acid in suitable proportion are used. So saturated fatty acids with 12 to 18 carbon atoms are used. Example is lauric acid, myristic, palmitic, stearic, and in the United States of America and Europe, tallow has long been used as a basic ingredient of soap. To improve the solubility and lathering properties, coconut oil is mixed with the tallow. Fish oils, palm oils, and coconut oils are also used in the preparation of soaps. Alkalis. Caustic soda is used as a raw material in the preparation of soap. Caustic potash is used in the making of soft soaps. Potassium carbonate and soda ash are used to saponify fatty acids. Additives used, antioxidants. So these are used to stabilize the soap against rancidity. Example, sodium silicate, sodium hyposulfite, sodium thiosulfite. Whiteners like titanium dioxide, zinc oxide are used to improve whiteness of the soap. So perfumes, the pH of the soap is around 10. The selected perfume should be stable in this pH range. Surfactant, primarily responsible for cleansing and lathering. That is the foam which you see when you apply the soap to your body. So non-ionic and amphoteric seldomly used. Example, alkaline or alkyl polyglucosides, fatty alcohols, alkyl phosphate esters, methyl glucose esters, glycerin monostearate, etc. Plasticizers and bounders. Plasticizers facilitate better extrusion and stamping of SYNDET bars. Also act by lowering the viscosity of the material at manufacturing temperature, providing flow under pressure. Example is long chain fatty acids greater than carbon 16 or more carbon chains than 16, that is polyesters, glycerol, monostearate, sorbitan stearate, glycol, distearate. So binders prevent separation of macroscopic aggregates, that is anti-cracking behavior. Fillers, cheaper ingredients used to reduce the bar cost. In case of synthets, fillers are not inert ingredients but participate in improving the internal structure and hardness. Example, dextrin, starch, modified starch, etc. So disadvantage of fillers is rough surface texture, loss of slip, loss of attractiveness. So what are used for formulation? That is sodium chloride, value sufficient, soap fatty esters, decyl glucosides, sequestrant, glycerin, vegetable oil or mineral oil, preservative, fragrance, and triethanolamine or citric acid, pigments, titanium dioxide, optical whiteness, water. Soap manufacturing can be done using four different processes. One is cold process, second one is semi-boiled process, third one is full boiled process, the fourth one is continuous saponification. Cold process, in this process mixing of fat and strong alkali is carried out substantially at room temperature so that little more than emulsification takes place. Saponification is completed after the mixture is run into frames in several days at warm temperature. Since here is no opportunity to adjust proportions of fat and alkali, calculation of quantities to be used should be made carefully. So semi-boiled process. The semi-boiled process differs from the cold process in the fact that the saponification mixture is heated to 70 to 90 degrees Celsius using a steam heated coil to accelerate the complete saponification reaction. See, when we see the normal saponification reaction or cold saponification reaction, there is no heat that is applied. It is done in a room temperature. Wherein semi-boiled process, you are increasing the temperatures to 70 to 90 degrees Celsius for more saponification or fast saponification reactions. Dyes, perfumes, and additives are added at the end of the process to prevent them from evaporating. The process allows the quantity of soda undergoing saponification to be adjusted before the crude soap is drawn off. Before removing the crude soap, you are going to allow soda that has to be adjusted. It also allows manufacturing waste to be recycled, better incorporation of additives, and a wider choice of raw materials. So this is how you prepare a semi-boiled process. That is oils and fats, soda lime. You are going to add perfumes and other dyes. You are going to mix it. Whereas a heating coil gives the proper required temperature, that is 70 to 90 degrees Celsius. So you will get a crude soap. And this crude soap is poured into a cooling frames from where you are going to collect the cooled soaps. Full boil process. In this process, large cylindrical kettles with cone bottoms equipped with open and sometimes with closed oils for steam are used. The kettles are often provided with delivery pipes for fats, water, and lime. Process included is saponification reaction, grinding out and washing, strong change, finishing or fitting operations. So this is how a commercially used fully boiled soap manufacturing process or a flow diagram. Continuous saponification. So these processes are used when the production is on large scale. Fats are first converted into fatty acids and glycerin using high pressure in continuous fat splitting process. So you have already converted, that is a continuous form when we are preparing in large scale. So other types of soaps are transparent soaps, bathing bars, castile soap, super fatted soaps, carbolic and carbonate soaps. So advantages and disadvantages of soaps are antibacterial, they can help kill germs. Its alkaline nature will irritate your skin. So test for the irritancy. So mild soaps can wash off the corrosive acids that drop on your skin and neutralize it. Lime soap formation. Soap loses its effectiveness in hard water that contain calcium and magnesium ions to form curd, leaving it undesirable deposits in wash basins, bathtubs, etc. So soaps are used for bathing, cleaning and washing. It also helps to skin clean. They also remove dirt, oil, makeup and other impurities on the skin. Whereas the disadvantages in some sensitive individuals, soap can also exhibit irritant properties. So irritation in some individuals may also occur when using alkali-free superfitted soaps that have extra fatty acids dosed or additives. Syndet bars. As we discussed, syndet bars are synthetic detergents. Ingredients used are sodium coil, isocyanate, sulfonoxyxenate, alpha olefin sulfonates, alkyl glycerol, ether sulfonates, and betanes. So syndet bars. Advantages: syndet bars perform well in hard water without formation of lime soap. The pH is close to neutral or comparable to pH of human skin. Many of the surfactants used in synthetic bars are relatively milder than normal or traditional soap. It can be used by individual having soap sensitive skin. They lack lubricity. They get easily become slimy because they get washed off early. Synthetic bars do not have the familiar feel of soap, which make consumer acceptance problematic and very difficult. They are not very popular as toilet tubes. Soap sources in red bar. Soap is extremely effective cleaning the skin. It strips away everything including our skin's natural oils. Whereas synthetic bars are mild and cause less damage to our skin. The pH of synthetic bars usually around 5.5 to 7. So this helps in where you can use it for babies, the baby soaps.